right?
What? Okay, I don't get that thing.
Because again, what are the places in base 6? Ones, sixes, right? And if I have the number 6 in our base, what's it going to look like in their base? How many 6s do they have? How many 6s do I have? One. I have 1 6 here, don't I?
Yeah.
So if I have the number 6 in our base, how do I put it in base 6? How many 6s does it have? 1. How many 1s does it have beyond that?
2.
None, right? Why does this symbol mean what it means for us? Because this is the tens place, and this is the ones place. So I have 1, 10, 0, 1s. Cool?
Okay.
So for them, they might call this 10, but who knows? And when they say 10, they know they actually mean this number of things. The real tricky part, so I want you to see this. On one level, this is just multiply and add, right? That's perfect. That'll get you through the homework, awesome. But if you can see the next level, where when I see this, for us it means the number 10 things. And we think this when we think 10. But they're not intrinsically the same thing. It's just that that's the way we called it. When somebody on another planet sees this symbol, they might say 10, and they know that represents the number 6. 6 things. So there's 2 different things going on. The symbol you use to represent something, and the thing that it actually represents. So this is so ingrained in our heads that this is 10 and it represents 10 things. There's no way to separate that. This is 10 and it represents 6 things if you're in base 6. If you're in base 11, this represents 11 things, right? So forth, right? How would you say 7 in base 6?
1.
How many 6s do you have? How many? You have 1 6, right? And how much extra do you have? 1. Cool, right? Okay, sort of. And what I'm kind of getting us towards is, how do you go the other way? From another base to our base is always easy. That sounds like a note. From another base to our base is always easier. From our base to another base is harder.
Which is what they asked in number 2.
I love it.
From their base to our base is easy.
Yes. From ours to somebody else's is more difficult. From somebody else's to ours, it's multiply and add. So probably from ours to theirs is going to involve division and subtraction, right? So let's see how that works. I think that's the last thing we'll do is this.
Is that like saying a base, their base is higher than our base?
Or lower, doesn't matter, whatever.
Oh.
Yeah. Higher base, I'm going to hold off on because, again, base 9, how many single digits does it need? Up to 8, because 9 would be 1 0.
Right.
Base 12, how many single digits does that need?
11.
So I need a single digit for 10 and a single digit for 11. So we're going to hold off on that. We'll get to that.
Well, that's the first question of the
Aw.
homework.
Well, we're going to get to it, well, sometime in the next 10 minutes. Right now, before I get there, I just want to deal with the smaller bases. They're easier to work with going the other way. So if I had, for example, let's start off small here. I want 15, base 10, converted to base 4, sure.
So 15 is the base 10, you said?
Yeah, this 15, what base is it already in? There's nothing here, so I know it's base 10. It's our base, because I don't have to say anything for that, right? But I want to convert that to a base 4 number. See how that's the backward? That's not the same thing over here? So we're starting in our base, going to somebody else's. So what are the places in base 4?
1, 4, 4.
So it always starts at 1, right?
Yes.
1, 4,
16.
16. Do I need that far up? Why not? Because that's bigger than the actual number, right? So I don't need that place. Do you see what I'm saying? Do I need that place? How many 16s are in 15? None. Right? But this is a good idea. Always go one more place than you need, just to make sure you went far enough. That's a good rule of thumb. So how many 4s are in 15? More than that? 3. Yeah. Aren't there 3 4s in 15?
Yeah.
What's the remainder? 15 minus 12? 3. 3 left over. And do you see, that's exactly what we did down here, isn't it? When we made 7 of base 6, there was 1, 6, and 7. And what's left? A 1, right? How many 4s are in 15? 3. And then how much is left? What's the remainder? 3. So 3 base 4 means the same thing as 15 in our base.
Oh,
So it's
go
3,
over
3,
it again.
How do you think that?
Yeah, I don't understand the 16.
All right,
Okay, kind of.
isn't this a place, can I go further? What's the next place in base 4?
4 to the
16
third.
times 4,
4 to the third.
64.
Okay, so it's
Do I need these to convert 15?
No.
no.
Because there isn't any 16s in 15, right? I don't need to go that far. But it's a good idea to go one place too far just to make sure that you went far enough. Now you just say, now what did we do over here? We said there I had 3 of these, I multiplied, 2 of these, I multiplied, then I added those, right? Now I'm just doing the reverse. I don't know what that is. These are blank places now, right? So how many 4s do I need to make 15? I need 3 4s. And then I need a little help from this guy, don't I?
Leftover.
3 4s don't quite make 15. I need 3 more. Cool. So this is like your remainder column, really, right? Same way it is in base 10. What's 12? It's 110 and 2 other things, right? 2 leftovers.
When you say 3 base 4 equal number 15.
Yes, 3 base 4 is the same thing as 15 base 10. They both represent the same amount of stuff. Because when you put 33 base 4 together, 3 4s plus 3 1s, it makes 15, right? Yes, ma'am.
Can you make a base be something that's over 10?
Yes, we're not going to do that yet. Almost. I want to do one more example with a smaller base like this, and then we'll talk about bigger bases. Yeah. Those. Have you guys ever seen? Have any of you guys ever seen like HTML code, like to make a web page? You ever seen how you refer to colors? F F E E O O. Have you guys ever seen?
Yeah.
So. If you go to their website, you can hit View Source, and you can see the actual code they use to make the website. And every now and again, you'll see like color, background color equals FF, AA 13.
When we copy and pasted them.
That's base 16. That's base 16 numbers. So yeah, we'll talk about that in a second. So how do I convert? Let's do it something bigger. How about 911? Convert to base, oh, I don't know. What sounds like a good base?
13.
No, I want to do a bigger base here. Let's convert it to base 9. So pretty much your first step on any of these kind of problems is write the places out, right? A little hangman game, right? And we're not sure how many places we're going to need. What's the first place going to be?
1.
Ones.
9.
Nines.
9 to the second.
81s,
81s.
81.
and then 9 to the 4th.
7, 29s. And you can see one more step is going to be too big. It's going to be 60, 400 and something.
65 is less.
65, what is it?
65.
65, 61?
No. We don't do this.
I don't need that, do I? Because
No.
how many of
It's
those
too
are in
big.
the none?
It's too big.
But that's what I mean. Go one step too far. Just make sure you actually went far enough. So what do I do? How many steps? Yes, ma'am.
So just real quick, the first one on the right is always going to be 1. It's not going to be 9.
Yeah,
to
this
1.
is 9 to the 0. It's always the
Oh,
thing
9
to
to
the
0.
0.
Okay, okay.
9 to the first, 9 squared, 9 cubed, 9 4 was too far. So how many 729s are in 911?
1.
There's 1. How much do I have left?
182. 182.
Wait,
Yes, ma'am. Go ahead.
how did you get the 1?
Well, how many 729s are in 911? How much can 729 cover for 911? 2 729s, isn't that too much?
281.
Yeah.
2 of these would be 1400
So we
something?
don't, so we don't do the whole division thing yet?
Yes, you do, but I really want you guys to see how most of these you don't have to do this. There's no purpose here for that. How many 729s are in 911? 1.
Ones.
2 of them is way too much, right?
Yeah.
And then how do you figure out how much is left to cover? You just subtract it, right? So sure, you could divide if you wanted to, but why do that? I know there's only one of these that can fit in there, right? And there's 182 left, so 81 can go into 182
2.
twice, right? So I got 2 81s, and that's 162.
And then 20 remaining.
So these 2 81s, cover 162 of that, right? Yes, ma'am.
Oh, why, how'd you get 4 lines?
Because I had to step out. This is the 1's place, the 9's place, the 81's place, the 729's place, the 65, 61, and right there I say, oh, that's too far.
So you go up until you pass it?
Because you don't know you've passed it until you actually pass
Yeah,
it.
so that's what I'm saying, like you go up.
That's what I meant. Always go one place too far, so then you know that's far enough,
Okay.
right?
Mhm.
So, one of these fit in there. So that takes care of 729 of it. There's 182 left to be taken care of. Two of these take care of 162 of it, so there's 20 left.
Two.
Two nines
18 and then 2.
And 2.
take care of 18 of it, so there's still 2 left. That's the remainder pile at the end. I didn't force it to be that. It's kind of cool it came out that way.
I like it.
So your answer would be
1, 2, 2, 2.
1,000.
So the actual answer would be 1, 2, 2, 2.
Base 9.
Base 9. Just make sure the people know that's not base 10. So last problem.
Yay.
Everybody's all like, I'm out of here. No.
So it's basically just a bunch of subtraction, and you might need to divide.
Yes, but
If
I
it
you know,
doesn't matter.
and again, to work this problem out, the math isn't that hard.
Just do this.
But the underlying idea that if I had a base 9 system, I would know that what that means without having to change it.
Can you do number 2 on the homework? Just because the way they word it doesn't make sense, and I'm so confused.
Oh, this is the same thing. If I have base 8, I go from 0 up to what digit? How far do I need? How much do I need in base 10? I need up to 9. How much do I need in base 8? Up to 7. Because how do I write 8? 1, 0. So in base 12, I need up to 11. 0, 1, 2, 3, 4.
Would just be 1.
Base 2, and what's base 2 also known as? Binary, computer code, 0, 1, 0, 0, 1, 1, 0, 1, 1, 0, right? That's base 2. That's exciting coming in.
Thank you.
So last little thing, what about, let's do base, let's just do base 12. Which means I need 0, 1, 2, 3, 8, 9. I need a single digit for 10.
So wait, I can't see.
A single digit for 10, don't I?
Yeah.
So, A.
Huh?
I can't use 0. I can't use 0 because 0 means 0.
Yeah.
So we just choose to use A.
Gotcha.
That's confusing.
So in base 12, what does the symbol A mean? 10. Why do we have to do that freakiness? You could actually use whatever you want to. If you would have been around when they decided this. You could have said, let's use this symbol. Or let's use this symbol. Right? The 3-eyed monster.
Any symbol
Happy
different than
bunch.
0, so you won't get confused.
8, 9,
Yeah.
10?
And what do you think 11 is?
B.
B.
Now watch. Why do we need that? Because if I were to write the number, what number, Jeff? I don't know. 139. What's base 12 going to have here?
1, 12, and
112, 144. That's too far, right?
Yes.
So that's that earlier thing about always make sure you go one step too far. So you know that's far enough.
So what's the
How many 12s are in 139?
11.
10.
Or 10. 11. Yeah.
11, right? With 7 left over. So there's 11 12s here.
Yeah.
We'll put that there for right now. And then how many 1s? Now, if I write, this is my answer.
Your twin.
Why is that wrong?
For a twin.
Don't tell me because I'm missing the 12. Let me put it through. Why is that wrong?
Because 12.
Because this will be the what place? That's in the
Third.
1's place. That's in the 12's place. And that's in the 144's place. I said I didn't need any 144's.
Yeah.
Where'd the mistake happen? I put 2 symbols in one place. Shit. Right? That's why we need a symbol for 11. One symbol, so I know that there's one place. The minute I put 1, 1, that looks like 2 places, right? So in base 12, this would be B7.
Why
B7.
Because what does B mean?
11.
B means 11. Do you guys see why we had to do that weirdness, though? If we use 11, it looks like 3 places, not 2. That's the only reason we had to come up with a single symbol. And actually using the letters is not really a terrible idea. It's better than using